So good morning again. As you can see in this slide, my name is Angela. I'm a forecaster in Portuguese Met Service in Lisbon. So before we continue, I always like to know where are you coming from. Thank you. So most of you are from the Eastern Europe. Okay. Thank you so much. So let's continue. So this is the Meteo Alarm webpage. So this is the warnings for today. And you can see some mostly yellow and some orange over north, mostly over north. And we have the weather events are mostly snow or ice, a cold, and some wind. And of course, we have some warnings in the islands, south, mostly from wind, and also some cold warning over the South Islands of Europe. So let's continue. This is the 6 UTC air mass RGB with mean sea level pressure and 500 hectopascal height. We have two deep troughs, one that's coming from the North Sea and goes from the North Sea, goes further south until here over over Morocco, and also with over here a cutoff low, and another one not so very well visible, but it still is here, from here, and go over south to the eastern Mediterranean. And an intense high over the Atlantic. It's very intense with 1042 hectopascal. It's really intense. And another one, not very well seen, but still here, reach over here. Not so intense, but it's still here. And further east, we have a low pressure system. And what we have more here, some interesting features. Over the Atlantic, there are some frontal cloudiness that we can see over here. There is approaching the British Isles, approaching a warm front shield. I can show you later where is the jet axis, and it is at the leading edge of the cloudiness. We have also an occlusion over here, and several areas of convective cloudiness. We have one over here, and also over south near Madeira, near Canary Islands, and Morocco. So this is the bluish and purple. Remember the colors of air mass RGB. So these are, it means it's a cold air mass, low tropopause, and we have some convection, as I said, in this area, this white. And of course, here in the Canary and Madeira Islands, we have some convection. And yesterday, we have some snow over Madeira and Canary Islands. And it's not very common in Madeira to have snow. We had it also has, I said, previous slide, there is also a warning from cold to Madeira. And we have some more regions of possible convection. We have one over here and also another one over here. And this is wealthy with some PV anomalies, this reddish color. It's well identified. And I show you later with the water vapor image. So this is dry descending air. It's related to high potential vorticity. Okay, just one remark. Don't forget that sometimes during winter and also during summer, but well, today we are in winter, we have the surface temperature is very low. So be careful when you are trying to see if we have warm air mass. You remember about the green color. And as I said, the surface temperature is very low during winter. So the brightness temperature difference between 9.7 and 10.8, which is in the green beam, is around 0. So we have more green. And so this is a remark about the color green that we have sometimes during winter. And it doesn't mean always that we have a warm air mass. In summer, we have the opposite situation, and it's red because the brightness temperature difference is very, very low. So between 9.7 and 10.8. So let's move on. This is to check the upper air dynamics, always checking the upper air dynamics with the water vapor image. So some features that are important to check. We have the position of jet stream, always important for not only for the dynamics and upper air dynamics, but also do not forget about the aviation. So we have some areas that could be of turbulence and severe turbulence. So it's a problem for aviation. Another feature, so we have some areas could be severe turbulence associated with this area of the jet stream. It's quite intense. Anyway, it's quite intense. So we have some moisture and dry boundaries. And these moisture and dry boundaries can be areas of convection initiation, so we have to be careful. Sometimes we have to check them, and before even we have some convection, and to be aware of these areas and pay attention in these areas. So we have some areas over here, also some over here, and of course also in area, but here we have some dry descending stratospheric air, so with high potential vorticity, and as I told you we are going maybe to have some thunderstorms over this area and also over this area. And also over here, some dry descending air, and in our air mass RGB, you saw some convection also over here. So to check some, mostly some low-level clouds or low water clouds, and use the night microphysics RGB, and this is the recipe over here. You can just remember, because I believe that everyone knows it. So we have some areas of low water clouds over here. These are stratus and stratocumulus. We have some patches of fog over here, and also some over north. And over this area, we have the high-level clouds that are red, and these are thick high-level clouds. And further east, we cannot use this night microphysics because of the contamination. Well, it's not contamination, but about the 3.9 and visible light. So some remarks about this night microphysics. It's very good for detect low clouds in the it's very good for detect low clouds because of the difference between the 10.8 and 3.9. It's around, the difference is between 6 to 10 degrees, and this is very useful to detect the low-level clouds. Nevertheless, this RGB has problems in high latitudes. So over here, it's a problem because we have the CO2 absorption by 3.9. The coal seams tend to contaminate 3.9, so 3.9 became noisy. So we have some problems. So for those who live in high latitudes, north of this area, and you have very cold temperatures during winter, it's better to use the night microphysics. Okay, let's move on. Just a very important area over here that I want to talk about. This frontal system is very powerful, and it's going to affect British Islands today, and later today and tomorrow is going to affect the northern, the area of Scandinavia. So important used to detect the warm air and to detect also the areas of frontal systems. We use this parameter here. It's the potential temperature at 850, and you can see here the warm air is being advected over the Atlantic and towards North Europe, this red area here. We have also over here some warm air advection through north with in fact, yesterday and the previous days, we had some positive anomalies of temperature positive anomalies over Albania, Turkey, and Cyprus. So it was quite warm in this area in the previous days. And we have, as I told you, the gradient zones over here that could help us find the surface front. Also, another parameter is also the term front parameter and the equivalent thickness. And we have over here the front and the warm front shield over here. And also we still have some occlusion associated with that trough I told you previous one over here that it's very well seen over here. In this area we have some warm advection. In this area, it's a warm front, and it's associated with this low pressure system that is going over here in Morocco. And another one to help us to find and detect warm fronts and cold fronts, we have the cold advection here, and as you can see, the the frontal cloud band is under cold advection. So this cold front is the type of anafront. And we have dipole of temperature advection over here, so it's still deepening this region over here with strong winds at surface, and it's moving towards affecting, as I said, affecting all this area with strong winds. And then we have here the 10-meter winds, just to confirm what I was talking about, this area with strong winds associated with this cyclogenesis. This area is still deepening this low pressure system, and this area is going to affect this the North Sea and British Islands in the next hours. Also, we have this area of high winds are. It's very important to be aware and pay attention for generation of waves. So we are going to have in a few hours, a day or two, we are going to have over this region some huge waves associated with this area of fetch. So let's move on for another issue, another event. During the past month, several weather events happened in Europe, with some of them with some huge consequences. But the one I'm going to talk about now did not have severe weather, at least as severe as we all expected. So I'm talking about Alex, the first hurricane of the season, or in other words, an out-of-season hurricane. So for those of you that may not be so familiar with the location of the Atlantic and west of Portugal mainland. Also here is Madeira Highlands. So there are 3 groups of islands: the West Group, the Central Group, and the East Group, and the total are 9 islands. So, first of all, some facts. And sorry about this slide with so many words, but I think it's worth it. So, Alex was first a subtropical storm, and it has some difference in the definition from the tropical storm itself. So, the tropical storm or a subtropical storm, they both have characteristics of tropical and extratropical cyclones. They are both non-frontal and synodic scale cyclones. They are both originating in tropic or subtropical. They have a closed surface wind circulation, and they also have organized moderate to deep convection. But a subtropical storm lacks a central dense overcast. The energy comes from baroclinic sources, and generally the cold core in the upper, it has a cold core in the upper troposphere. So these are the highlights, more or less, of the definition of a subtropical storm. If you want to see the complete definition, go to National Hurricane Center webpage, and you can find it there. So more facts about Alex. It was the first hurricane to form in Atlantic in January since 1938. It was the first hurricane to occur in January since Alice of 1955, and it also was the second hurricane on record to develop north of 30 degrees north and east of 30 degrees west. So The first one was Vince in 2005, and this one also an hurricane that affected Madeira Islands. So about the causes or main causes or possible causes for the transition to a tropical storm and later intensification for hurricane, it seems that the low pressure system that later developed in a tropical storm moved over ocean waters that were near 20 degrees. And there was in the region also some areas of sea surface temperature that were above average, this from January mean. In the upper levels, we had a trough, so the upper tropospheric temperature estimated to be around minus 60 degrees. So these both reasons resulting in convective instability. So it means that it may be the main factor to a tropical transition and intensification. So the thunderstorm that resulted could warm the upper levels. So the low pressure system that later originates Alex is here in this green box on 7 January at 12 UTC near Florida. And it was already a gale storm, depression with gale winds over here. So already some deep low in this region. So it moves a little bit north, and in the next days will be on 9 January, will be near Bermuda, and then go further south over here and go there, and became a subtropical storm on 13 January at 9 UTC, 21 UTC. And it also stayed in this area over here. And in 14 January at 15 UTC, it became a hurricane. Then later at 15 January, 21 UTC, it was already a post-tropical cyclone, and it was in this area north of Azores and moved north, as I'm going to show you in the next slide. So here it is on 15 January at 18 UTC. We still have a tropical storm over here, and then it moved north through this region and was absorbed by this system over here. So let's show some yes, okay, some images about Alex. This one is this is one from visible, high resolution visible, and it's very interesting, this image, because it has a low angle of the sun, and we have some shadows that allow to see several details, and we can see the eye over here, and we have some convection. It's going over here, and some also over here, some convection. Okay, let's move on. Another one from VIRS, from the NPP satellite, and also it's very interesting to see these mountain waves over here. I hope you can see it. This is from islands here, one of the islands in the East Group, and it's very nice to see. And this was later during the afternoon of the 15th January, and you can see more or less the center over here of the tropical storm. At this time, it was already a tropical storm, Alex. And another one from Moody's. This is also very interesting because we have some many details, and we can see some convection over here, and the center of the tropical storm is very well seen. This image is made with with several SWOTs, so be careful. It's some composite of images of SWOTs. It's between 1155 and 50. So METOP also saw saw Alex. So this is ASCAT from METOP A. This is a descending path between 1121 and 1124 UTC, and you can see the areas over here north of Azores. With high values of winds, you can see between 30 and 35, and even between 40 and 45 knots in this area. The northeastern winds in this region. Over Azores, as you can see at this time, we didn't have as much winds as we thought we could have. So finally, just to say that Alex didn't have a big impact. The observations were not so impressive, and mainly the highest values happen during the morning. So we have the wind gusts, 88.6 kilometers per hour in this station over here. Also, this station reported 16 millimeters between 8 and 9 UTC. We have some rain over here, south of this island here, 13 millimeters. And this station reports a total amount in 12 hours of 93.6 millimeters between the 23 UTC the previous day and 11 UTC on 15 January. So Alex went this trajectory more or less, and it didn't quite make the landfall. It was more or less 20 kilometers from the coast, and the time here, this island was about 13-15 with the use of satellite images. So that's all for today. I hope you have enjoyed. This one is the last image. It shows tropical storm Alex. At this time, it was already a tropical storm near the central group at 11:55 UTC. This is the air mass RGB. So thank you again. Just to say, the next weather briefing will be on 17 March by Marcin Korski at 12 UTC or 9, I'm not sure about 12 UTC, I'm sorry, but you can check in the EUMeTrain webpage. Thank you again. If you have some questions or comments, you are welcome. Thank you.